Traditionally, when you build a car, you start with the chassis. It's physical, it's steel, and it's entirely measurable.
Right, you bolt the engine in, you attach the wheel.
Yeah, exactly. And that structural foundation, it just never fundamentally changes. The vehicle rolls off the line, and mechanically speaking, that is the best it will ever be.
Right.
But when you step into the world of software-defined vehicles, that chassis basically becomes invisible. We're looking at a foundation that is entirely digital, it's constantly shifting, and right now, it is the site of this massive industry-wide power struggle.
Oh, absolutely.
We aren't just changing how the car drives anymore. We're changing who actually owns its nervous system. Navigating that power struggle is exactly what today's deep dive is about. But really quick before we jump in, brought to you by Thomas Allgaier and Frennis, this edition highlights key LinkedIn posts on next-gen vehicle intelligence in week 13 and 14. Frennis supports Tier 1 automotive suppliers with early-stage market validation for their R&D efforts by combining secondary research, direct OEM expert interviews, and facilitated customer meetings. You can find more info in the description.
Awesome. Well, welcome to the deep dive. Look, if you are a mobility professional navigating this transition,
right,
you already know the landscape is incredibly noisy.
Yeah, there's so much marketing fluff out there.
Exactly. So our mission today is to just cut through that noise. We're looking at the top next-gen vehicle intelligence trends curated directly from the conversations happening across the industry, specifically in calendar weeks 13 and 14.
Right.
We are stripping away the high-level PR stuff and looking at what the engineers, the strategists, and executives are actually debating on the ground.
And, the first big thing we have to talk about is how the era of the isolated ECU is just over. We've spent decades building cars where literally every function.
Yeah, from the windshield wipers to the anti-lock brakes.
Right. They all had their own dedicated little computer box. But now the new battleground is consolidating all of that. It's all about figuring out who actually gets to own the underlying software platform that runs the whole show.
Yeah, and the biggest shockwave on that front over the last couple of weeks definitely came from Google. They officially launched Android Automotive OS for software-defined vehicles, which they're calling AAOS SDV.
Wow. Okay.
Yeah, and Hinchem Simudi and Jack Dunkley both pointed out a really critical shift in Google's strategy here, because they are no longer just aiming to control your infotainment screen.
Right. They want the whole thing.
Exactly. They want the entire stack. We are talking body functions, climate control, lighting systems, the core compute architecture, and even the over-the-air update infrastructure.
So they're moving from the dashboard directly into the vehicle's actual internal software fabric.
Yeah, and the crazy part is they did it by open sourcing the OS. Benjamin Herman had a brilliant perspective on this. He called it the Android playbook.
Oh, I like that.
Right, because if you look back at, say, 2014, Google just handed every car manufacturer a simple, free USB cable to get Android Auto onto their screens.
Yeah, and some OEMs resisted. They tried to build their own clunky alternative.
Totally, but Google just waited. And now, here in 2026, they aren't offering a cable. They're offering a completely free open-source nervous system for the car, which, immediately commoditizes what legacy automakers have literally spent billions trying to build independently.
It's basically an existential crisis for the traditional automaker at this point. Augustin Friedel brought up this concept of the AV sandwich, which perfectly illustrates it.
The AV sandwich.
Yeah, so if you look at the digital architecture of a modern vehicle, the OEMs are getting squeezed from both sides. So at the bottom layer, you've got the silicon giants providing the sheer hardware compute power.
Right.
And then at the top layer, you have the massive cloud hyperscalers managing all the off-board data. And right in the middle is this really thin layer of the stack. It's the application layer that actually interacts with the driver.
And that interaction layer is where the assistant lives. It's where the brand actually gets to speak to the consumer.
Exactly. But Friedel warns that OEMs risk losing that specific layer entirely. Because if you cede the interaction model to Google or, another tech giant, you lose the monetization opportunities.
You lose control over the user experience, too.
Yeah, and most importantly, you lose the continuous data loop. Your historic automotive brand just disappears behind someone else's digital interface, and you're left acting as a low-margin hardware provider.
Yeah, but let me push back a little here. Are OEMs really just rolling over and accepting this? I don't see how legacy OEMs survive this, honestly. Google has infinite capital and basically the best software engineers on the planet.
Right.
So why shouldn't company like VW or BMW just take the free operating system, save the billions they're currently burning on software R&D, and just focus on building phenomenally good hardware? Handing over the digital keys kind of seems inevitable if they want to stay profitable.
We'll see. Taking the free OS is really tempting in the short term, but it is fatal in the long term. And Andrew Bullen shared some crucial insights on how the leading players are actively fighting this vendor lock-in.
Okay, so how are they fighting it?
Well, leading automakers, companies like BMW, Mercedes, and Volvo, they aren't rolling over. They are deploying what's called a layered architecture strategy.
Break down the mechanics of that for me. How does a layered architecture actually stop a tech giant from taking over the data loop?
So instead of handing the entire vertical stack over to one provider, they isolate the layers. At the very base, they use a neutral, highly secure, safety-certified foundation, something like QNX.
Okay.
Then, for the heavy lifting, they bring in NVIDIA or Qualcomm to handle the massive AI compute performance. But crucially, the OEM builds a proprietary firewall around the very top layer.
So they maintain absolute control over the brand interface.
Exactly. The brand interface, the customer data, and the overarching vehicle intelligence. It's essentially strategic supplier management. They extract the best pieces of technology from the giants without actually surrendering their long-term leverage.
That makes a lot of sense. And look, if you're an engineer or product manager listening to this right now, you are standing at a very real strategic fork in the road. You really have to ask yourself, are you designing your component to live seamlessly in an open, standardized Google ecosystem? Or are you preparing your product to integrate with these fiercely guarded proprietary OEM layers?
Yeah, because those two paths require fundamentally different engineering and compliance strategies.
Exactly. And that strategic divergence leads directly into the next massive challenge we saw trending. Because if an OEM successfully defends and builds that bottom software layer, well, the immediate problem becomes managing the sheer volume of code running on it.
Right. Traditional deterministic code, where a human programmer writes a specific rule for every single scenario, is just failing to scale.
It is, and that is exactly why the industry is aggressively pivoting to AI. We are officially moving from software-defined vehicles to AI-defined vehicles, or AIDVs.
Yes, AIDVs. Dr. Marina Zebian and Pranay Agrawal broke down Qualcomm's Snapdragon digital chassis recently, and it just illustrates this pivot perfectly. I mean, AI is no longer a localized feature like a voice assistant that you just layer on top of the software at the end of the development cycle.
No, not at all. AI is becoming the architectural foundation itself.
Exactly. In an AI-defined vehicle, the car basically operates as a network of cooperating AI agents.
Yeah, you have agents processing the ADS, the advanced driver assistance systems. You have different agents managing the digital cockpit and others handling telematics.
Right, and they use on-edge language and vision models combined with cloud intelligence to share context. So the vehicle stops following rigid, pre-programmed rules and begins reasoning, adapting, and actually learning from the entire fleet's data in real time.
It's incredible. But relying on AI to write and manage code introduces a really severe hidden danger. And Robert Fay highlighted a concept that I think is critical for any engineering team to understand right now, which is debugging collapse.
Debugging collapse. That sounds ominous.
It is. A lot of organizations are super thrilled about using AI to generate software tests. And, on paper, it looks like massive progress. You get exponentially more tests, higher code coverage, faster execution time.
Right, everybody loves faster execution.
But Fay points out that AI does not actually remove the engineering bottleneck. It just relocates it. It moves the bottleneck from the creation of the tests to the human comprehension of the failures.
Right.
The math he provided is a pretty stark reality check.
Mm-hmm.
So imagine your AI generates and runs 50,000 automated tests overnight. 48,800 of them pass perfectly.
Okay.
But 1,200 fail.
Yeah. And here is where the system just totally breaks down. Because if it takes a human engineer, say, just 1 to 2 hours to unpack a complex AI-generated failure, trace the logic back through the neural net and actually debug it.
Right.
That is up to 2,400 hours of manual debugging generated from a single overnight test run.
It's insane.
It really is. It's like cranking up a factory assembly line to 10 times its normal speed, but then firing all the quality control inspectors at the end. I mean, you aren't scaling your software quality. You are literally just scaling your confusion.
That is a perfect analogy. Humans simply do not scale linearly with AI output. So if your system cannot automatically explain its own failures, the AI is just amplifying your uncertainty.
And when you are engineering a 2-ton machine moving at highway speeds, uncertainty is just unacceptable.
Exactly. Which is why Imran Khan and George Pasca weighed in heavily on the functional safety side of this AI explosion, specifically looking at the ISO 26262 standard.
Yeah, Khan made the vital point that functional safety is really the quiet discipline holding this entire transition together. I mean, in complex AI architectures, faults are going to inevitably occur.
Right, it's unavoidable.
And when they do, the vehicle must transition to a safe state predictably. You cannot just bolt functional safety on later through testing. It has to be architected into the bedrock from day one.
Yeah, and Pasca highlighted a really specific danger in this integration process, which is the SEOE, or safety element out of context.
Oh yeah, the SEOC.
To put this in perspective, building software out of context, it's kind of like buying this state-of-the-art pacemaker, right? But then trying to wire it into a patient whose heart has a completely different voltage requirement. The pacemaker works perfectly in a vacuum, but the actual integration will be fatal.
Right. So in software terms, a COC is basically when a Tier 1 supplier develops a safety-related component based entirely on assumptions. They don't actually know the specific final vehicle architecture it will inhabit.
Exactly. You might engineer your component assuming it will live in an ASIL-D environment.
Yeah.
And ASIL-D is the highest automotive safety integrity level, think steering or braking systems that require massive dual-core redundancy.
Right, so if one processor fails, the other instantly takes over.
Exactly. But then the automaker takes your ASIL-D component and integrates it into a subsystem that only supports ASIL-B. That's a much lower safety level, like a cluster display, which just lacks that deep redundancy.
So the component assumes a safety net exists that simply isn't there.
Yep. And when those assumptions clash during late-stage integration, the architecture breaks. The engineers panic. And under massive deadline pressure, they write what Pasca calls glue code just to force the mismatched pieces to communicate.
Wow. Writing rushed glue code for a safety-critical AI system sounds like an absolute recipe for disaster.
It is. Without rigorous gap analysis early in the process, the entire vehicle's safety argument basically just falls apart.
And I think this friction between elegant software theory and messy physical integration exposes the core vulnerability of the entire industry. You can design the most sophisticated layered architecture and you can train the most advanced AI models, but I mean, if your organization lacks the structural discipline to actually build it, the strategy is completely worthless.
Oh, totally. And we saw a pretty brutal contrast in execution capability just in the last 2 weeks alone.
Yeah, Prasanth Gorvahala wrote about the cancellation of Afeela, which, was the highly anticipated joint venture between Sony and Honda Mobility.
Right. That was supposed to be a flagship software-defined vehicle packed with all these ambitious infotainment and gaming features.
But they shut it down. And the lesson there is that SDV success requires a robust, scalable underlying architecture. A wish list of high-tech features just cannot compensate for a weak structural foundation.
Absolutely.
Yeah.
And then you contrast that Afeela cancellation with the update shared by Brian Carlson and Wassim Bensaid. Because Volkswagen and Rivian just successfully completed rigorous winter testing of their new zonal architecture.
Which is huge.
It is. It proves it works across both mass market and premium vehicle lines.
Yeah, and just for some context here, traditional vehicles use a domain architecture, meaning they have, over 100 different computing boxes scattered throughout the car, connected by miles of heavy copper wiring.
Right.
But zonal architecture rips all of that out. It groups the compute power by physical location, or zones, and routes everything back to a few central supercomputers. So it saves weight, it cuts costs, and it centralizes the software. But actually rewiring a vehicle's entire physical layout is just incredibly difficult to execute.
Exactly. And because VW and Rivian actually achieved that technical proof point in the harsh conditions of winter testing, it unlocked an additional $1 billion investment from VW into their joint venture.
Wow, $1 billion.
Yeah. In the mobility sector today, PowerPoint presentations just no longer secure capital. Disciplined execution and tangible technical milestones are essentially the only currency that matters.
So why is it so notoriously difficult for legacy automakers to actually execute on this level? I mean, Marcus Redstedt and Vinicius Tadeu-Zain argued that the failure to scale SDVs is not caused by a talent gap at all.
No, not at all. Automakers have hired thousands of brilliant software engineers.
Right. The failure is actually caused by organizational politics. Redstadt describes it as a mechanical hangover.
A mechanical hangover. I love that. Because traditional auto teams are basically trapped by Conway's Law.
Conway's Law, that's the one that states that an organization will design software systems that mirror its own internal communication structures.
Exactly. Legacy OEMs have spent a century operating in these really rigid physical silos. The powertrain team sits in one building, the infotainment team sits in another, and they just rarely speak.
And if you're a software engineer at a Tier 1 supplier, you know exactly what this feels like. You write a piece of code that needs to interact with both the battery management system and the dashboard display.
Right.
But because the OEM's battery team and display team operate as rival fiefdoms, you end up spending 6 weeks just waiting for a cross-departmental integration approval.
It's a nightmare. You end up with a fragmented, fragile software architecture strictly because the company itself is fragmented. Redstadt made a profound observation here. Architecture is management.
Wow.
Yeah. An automotive company only truly becomes software-defined when its technical architecture finally overrides its internal politics.
And this organizational paralysis is precisely why everyone in the West is terrified of China's speed.
Oh, absolutely. Martin Schleicher analyzed whether the European automotive industry can actually move at the velocity of Chinese EV manufacturers. And his conclusion is fascinating.
What did he find?
He says European OEMs absolutely can move at China's speed, but currently they only do it when they enter what he calls task force mode.
Task force mode. So that's what happens when a massive crisis hits, right? Like a critical recall or a bug that's going to delay a major launch.
Exactly. Suddenly the organizational chart just evaporates. The silos vanish. The OEM and the suppliers put all their engineers in one single room. Executives make localized decisions in real time without needing committee approval, and they achieve this incredible velocity.
But the catch is, the moment the crisis is resolved, the company just reverts right back to its standard operating procedure, which is this massive bureaucracy optimized entirely for risk avoidance rather than value creation. It's basically like cramming for a college final the night before.
Yeah.
I mean, sure, you might pass the test this time, but it's an exhausting, unsustainable way to run a multi-billion-dollar business. You just cannot base your long-term software strategy on permanent adrenaline.
You really can't. And time is rapidly running out to fix that operating model.
Oh.
Pedro Pacheco outlined the immediate stakes here, pointing to the upcoming launches of the BMW iX3 and the Mercedes CLA in the Chinese market.
Right. These specific vehicles are designed to be Europe's definitive technological response to China's overwhelming EV and SDV dominance.
Exactly. And Pacheco warns that these models simply must win in China. I mean, historically, a German automaker could command a significant price premium strictly based on the heritage of their badge.
Yeah. But Chinese consumers today have a vast array of domestic options that excel in software, AI integration, and digital safety, and they do it all at a lower price point.
Exactly. The badge alone just no longer justifies the cost.
So if the iX3 and the CLA fail to capture market share, it sends a really chilling signal that traditional OEMs might lack the structural breakthroughs required to fend off Chinese competitors on a global scale.
Yeah, the war for the software-defined vehicle is literally being fought and won in China right now.
Absolutely. And, when you synthesize all of these massive shifts, the battle for platform ownership, the transition to AI native intelligence, and the desperate need to overcome these internal silos to achieve execution speed, it points toward a fundamental transformation in the life cycle of the vehicle itself.
Right. Which actually brings us to a final, really provocative trend that is quietly reshaping a massive sector of the industry.
Yeah.
And that is the aftermarket.
Oh, yeah. Pablo Telleria-Bassadone dropped some staggering insights regarding this. I mean, the automotive aftermarket is a $512 billion global industry. And right now, it relies entirely on things breaking down and humans physically fixing them.
Right.
But AI-defined vehicles are radically altering that dynamic. Just consider the sheer data volume. A modern connected vehicle is now generating up to 25 gigabytes of driving and system data every single hour.
That is massive.
It is. And Bassadone points out that if OEMs successfully leverage that continuous data stream for predictive maintenance, we could see a 50% reduction in unexpected vehicle breakdowns.
Wow.
Furthermore, utilizing this connected data could allow regulators and automakers to detect 70% of U.S. vehicle recalls far earlier than they do today, which would prevent massive physical service campaigns. That's incredible. So, if you're building the future of mobility, here's the final thought for you to consider. As these AI-defined vehicles become capable of self-diagnosing their own systemic issues in real time and deploying their own software patches through continuous over-the-air updates, what actually happens to the physical infrastructure we rely on?
Right.
Will the traditional dealership service center even exist in its current form 5 years from now? Or will your vehicle simply fix its own nervous system while it sits parked in your driveway overnight?
It's wild to think about. Obviously, the mechanical chassis will always require physical maintenance. Tires wear out, brake pads degrade.
Sure.
But the digital foundation, that invisible, constantly shifting architecture we started this discussion with, there's going to require a completely different ecosystem of care. And the companies that figure out how to service that digital chassis will ultimately own the next era of mobility.
If you enjoyed this episode, new episodes drop every 2 weeks. Also, check out our other editions on electrification and battery technology, future mobility and market evolution, and commercial fleet insights.
Thank you so much for joining us on this deep dive. Keep building, keep questioning the underlying assumptions in your own architecture, and make sure to subscribe so you never miss an update. See you next time.